In lesson 9.2, we talk about the converse of the Pythagorean theorem. This merely means that if the lengths of the triangle satisfy the Pythagorean theorem, then the triangle has to be a right triangle. The regular Pythagorean theorem says that in a right triangle we have a squared plus b squared equals c squared. This is saying the reverse, that if we do have a squared plus b squared equals c squared, then we have a right triangle. So if I write it for you, this is the normal way the Pythagorean theorem is read. It says a squared plus b squared, no, sorry. Let me say, what I meant is, if a right triangle, then a squared plus b squared equals c squared. Whereas the converse means if a squared plus b squared equals c squared, then it's a right triangle. And what you'll notice is all this means is that our wording has flip-flopped from one way to the other. And the interesting thing is in math, the converses are not always true. For example, all squares are rectangles is not the same as saying all rectangles are squares. So just because one thing's true doesn't mean its converse is true. So the nice thing is, in a Pythagorean theorem, you can go either way. If you know you have a right triangle, then the leg squared plus the leg squared equals the hypotenuse squared. Or if you know that the leg squared plus the leg squared equals the hypotenuse squared, then you know it has to be a right triangle. And they use the letters A, B, and C, of course. So the big idea in lesson 9.2 is that the Pythagorean theorem can go forwards or backwards, or in other words, its converse is also true.